Hello friends, welcome to Basic Electrical YouTube channel. So in this lecture, we are going to solve problems on three-phase induction motor. See, I am going to solve around 14 to 15 problems. It's going to cover all types. Okay. So let's first start with the VTU model paper problem itself. So see, this is class number 6, problems part number 1. So in part number 1, I am going to do it around 5 to 6 problems. Okay, please go through that. It may be a lengthy videos, but I am making all the problems in one video. 6 problems in one video means obviously it will take 30 minutes. Okay, please watch the problems with lot of patience. Okay, definitely it will give you full marks in university examination. So let's start with first question. This question asked in VTU model paper for new scheme, and the marks is 6 mark. Let me read the question. A 3-phase 400 volt 50 hertz supply is given to 3-phase induction motor. So there is an induction motor. Okay, for this induction motor, 3-phase supply is given. 3-phase supply is given. What are the specification? 400 volt 50 hertz. Okay, got it? Given to induction motor with 4 poles. How many poles in induction motor? 4 pole. Okay, with 4 pole running, and the motor runs at 1440 rpm. Okay, motor runs at 1440 rpm. Okay, so this is at this speed the motor is running. Determine, now they are asking, determine the speed of rotor and frequency of rotor current. Determine the speed of rotor and frequency of rotor current. See, in model paper they have made a wrong question. Okay, see, motor runs at a speed, that speed is called n. Again they are asking what is speed of the rotor. Okay, so the corrected question is, they should ask here, determine synchronous speed. See, this part of the question has to be changed. So determine the synchronous speed they should ask. Determine synchronous speed. Because in induction motor there will be 2 speeds. One is called synchronous speed, denoted as ns. What is this speed? This speed is speed of rotating magnetic field, that is ns, and speed of rotor is n. Because they already given here with 4 pole running and runs at 1440 rpm means what it's running? Rotor only. How can they ask again determine the speed of rotor? So in question paper, question will be correct only. So unknowingly typing mistake. So in the model paper they are asking determine speed of the rotor. So you corrected this question by determine the synchronous speed. Okay, so this also data given. So now what is synchronous speed formula? Synchronous speed formula is 120f by p. P is nothing but number of poles. So 120 into, what is the frequency? See, motor is connected to supply. Supply frequency is this one. F is called supply frequency. F4 is called rotor frequency. Got it? So now, what is F? 50 hertz. 120 into 50 divided by 4. So this becomes 1500 rpm. Okay, the synchronous speed is 1500 rpm. So this is what the first question. They should ask like this: determine synchronous speed. Mistakenly typing error. So now, next, frequency of rotor current. See, we know the formula for frequency of rotor current. Frequency of rotor current is Fr is equal to S into F. Slip times of supply frequency is called rotor frequency. Now, we know the supply frequency. How much? 50 hertz. Okay, 50 hertz is supply frequency. Now, I need to calculate slip. What is slip value? So, slip formula is S is equal to ns minus n divided by ns. See, this S is absolute slip. Okay, means in fraction you write. Okay, if you written here into 100, then this become percentage slip. Percentage slip is not required in this equation. We need absolute slip. So let me calculate this. What is NS? 1500. So NS is 1500 minus what is the speed of the rotor? Motor runs at what speed? 1440. So 1440 divided by what is NS? Very good, 1500. Now calculate by using calculator. 1500 minus 1440. So divided by 1500. So by doing this, what value you got? 0.04. Very good. So we got slip value 0.04. Slip is 0.04. See, in previous lecture I given concept of slip and its significance. What is the range of slip for good induction motor? Everything, all the details already given in previous lecture. Please go through that lecture. That lecture will give strong foundation to understand the problems on three-phase induction motor. Got it? See, now your slip answer should come from 1% to 4%. Otherwise 0.01 to 0.05. 1% to 5%. That is the range of slip for good induction motor. Got it? So we got almost the range within suitable for good induction motor. So slip answer is this much. Now calculate FR. See, frequency of rotor current is FR. If they ask frequency of rotor induced EMF is also FR. Frequency of rotor current also FR. So FR is equal to S into F. What is the value of slip? 0.04. What is the value of supply frequency? 50. So multiply this, 5 4s are 20, you will get 2 Hertz. Okay. So rotor frequency is 2 Hertz. Got it? So this question asked in VTU model paper. Only silly mistake is they should ask determine synchronous speed. Instead that they are asking speed of rotor itself. So then they cannot give this data. Understood? So pause the video, copy down the problem. Okay friends, now we can solve question number 2. See, this question number 2 is 95% same as question number 1. Okay. See, in previous question also they asked for 4 poles and they given speed 1440 RPM. Now they given 1470 and they are asking find synchronous speed, slip and frequency of induced EMF in the rotor. Induced EMF in the rotor under this condition. Okay. So this problem is also important. So what is the difference? 5% is different. That difference is in this problem they are not given supply frequency. Okay. So it is a concept based problem. Looks similar to question number 1, but lot of concept in this. Okay, got it? So what to do when supply frequency is not given? How to proceed the problem? Okay, that is important thing. So you cannot leave this question in exam. Frequency data is not given, question is wrong. Like that you need not to write. Okay. So the students know the subject very well. So there are some conditions. Okay. There are some procedure there. When data is not given, how to take out the problems. So let's start. Induction motor. Okay. How many poles in the induction motor? 4 poles. A 4-pole 3-phase induction motor runs at a speed of 1470 RPM. So induction motor running at 1470 RPM. That is N value. And they are asking find synchronous speed. Okay. And then slip. Okay. What is the value of slip? And also they are asking what is rotor frequency of the what is the frequency of induced EMF in the rotor? That is FR. They can ask rotor current frequency or rotor induced EMF frequency. Everything is FR only. Okay. Under this condition is on such conditions. See, now to find NS, we have a formula. NS is equal to 120 F by P. Now they are given poles. Okay. We know N value. to become induction motor, what is the condition? Ns value should be more than N. Your Ns value should come more than N. Okay. But frequency is not given. When frequency is not given, you can assume either 50 Hz or 60 Hz. All over the world, we have two standard frequency. India and Europe countries has 50 Hz and other countries have 60 Hz. Some countries have two frequencies, either 50 or 60 Hz. We can do analysis by taking f is equal to 50 Hz. What Ns we will get, we can check out. Similarly, by taking 60 Hz, then also we can calculate Ns. Let's calculate Ns by taking f is equal to 50. So 120 in this formula, put f is equal to 50. So 120 into 50 divided by, what is the number of poles? 4 poles. So divided by 4. 120 into 50 divided by 4, how much you get? 1500. So this is Ns value. So when I taken frequency 50 Hz, I got Ns value 1500. Is it satisfying the condition? Yes, Ns is more than N. So definitely this can be a speed. This can be a synchronous speed. But data is not given frequency. There may be a chance of this also. We can check out there also now. So Ns is equal to 120 f by 120 into frequency is 60 divided by number of poles is 4 poles. See, from this we get Ns value 1800 rpm. Using calculator you can find this. Ns is 1800 rpm, and here see, both the condition is satisfying. To behave like induction motor, Ns should be more than N. So 1500 is more than 1470 and 1800 also more than 1470. So but I cannot take both the speed. I cannot take both frequencies. The induction motor runs at either 50 or 60. You cannot give both the frequencies. You have to give a justification, either 50 or 60 only you should select. Okay. Then this is one condition. We have another condition that is called slip condition. Okay. Slip. For a good induction motor, the value of slip is in the range of 0.01 to 0.05. That is from 1% to 5%. Okay. The percentage slip. If your slip value lies between this range, then it is called good induction motor. There can be Ns may be more than N. Of course, it is like induction motor only. But good induction motor is important. So, to good induction motor, your slip answer should lies between 0.01 to 0.05. Let's calculate slip. Calculate slip when Ns is 1500 and also when Ns is 1800. So, what is slip formula? Ns minus N by Ns. So, Ns is 1500 minus N is 1470 divided by 1500. If you do this, you will get a slip value 0.02. So, we got slip 0.02. Is this slip within this range? 0.01 to 0.05. Yes, it is in this range. Let me check that also. So, now slip is equal to Ns minus N divided by Ns. So Ns is 1800 minus rotor speed is, what is the rotor speed? 1470. So divided by 1800. If you do this in calculator, you will get 0.183. Okay, that is the value of slip. If you multiply this by 100, 0.183 becomes 18.3%. Okay. If you multiply this by 100, 0.02 into 100, if you multiply, you will get 2%. So 2% is within this range, 1 to 5%. But that is 18%. See now what is this value? 0.183. So that slip value is not in this range. So therefore, this one you cannot take it. Okay, understood? See, Ns condition is valid to behave like induction motor. By checking good induction motor condition, so slip is not comes within our range, within the given range, so that's why it is cancelled. Okay, you need not to consider whatever I done calculation under 60 years is finally cancelled, ruled out. So then now what is the correct value? NS is equal to 1500. Based on this, by checking NS is more than N condition and slip range condition, both conditions are satisfied. Therefore, you can directly write NS value is 1500. Okay. See, NS is more than N. Very good. Then slip is 1 to 2%, 1 to 5% within that range. Yes, we have that range. So both are valid. So therefore your synchro speed itself 1500. Okay. Then slip. What is the slip answer? Slip answer is 0.02. Need not to recalculate again because you check the condition. Both condition is valid. Slip condition and speed condition. Everything is valid. Okay. By taking what? F is equal to 50. At 60 hertz speed is valid, but slip is not satisfied. So you can rule out that. So next one is finally frequency of induced EMF in the rotor under this condition. So what is rotor frequency formula? Rotor frequency is slip into supply frequency. Which slip you are going to take? 0.02 or 0.183? Very good. This one only. 0.02 into what is the supply frequency? 50 hertz. So 0.02 into 50, the answer will be 1 hertz. See, rotor frequency will be very low under running condition. See, the rotor is running at this speed. Obviously, the rotor frequency will be very less. Okay. At standstill, the rotor frequency and supply frequency both are equal. Okay, need not to worry. We can learn such concepts in the upcoming problems. Understood? See, don't give up the problem because frequency is not given in this problem. You have to assume either 50 or 60. Then don't assume 40 hertz. If you assume 40 hertz, calculate NS. If you got NS value more than N, then that frequency also valid. Okay, got it? Understood? But you can take standard frequency, either 50 or 60 hertz. Okay, got it? Important point is, for induction motor, NS value should be always more than N. Then only it is induction motor. And good induction motor is, your slip answer should come 1% to 5%. Okay, that is percentage slip. Absolute slip is 0.0 into 0.05. Please pause the video, copy down neatly. Okay friends, next is question number 3. So now this is a slightly different question. Okay. So let me read this. This question also asked in VTU for 6 marks. See, induction motor problems will be maximum 8 marks, minimum 4 marks. In an average, they can ask 6 marks problem. See, they are given now a 6-pole induction motor. See, there is an induction motor. Okay, induction motor. How many number of poles? 6 pole. Okay. This motor is getting, induction motor is supplied by a 10-pole alternator. Okay. There is an alternator. Okay. Alternator is having how many number of poles? 10-pole alternator. Then you are thinking that why alternator is given in induction motor topic? See guys, induction motor means what? Electrical to mechanical. What is alternator? Mechanical to electrical. So some mechanical input is given to alternator. Alternator going to the armature in the alternator cuts the flux, EMF will be induced. That induced EMF is having certain frequency, that is electrical quantity. That electrical supply, because induction motor requires what? Electrical supply. So alternator will going to give supply to this induction motor. That's why they written a 6-pole induction motor is supplied by 10-pole alternator. Okay. See, the alternator is given only for namesake. Okay. What we need frequency, supply frequency for induction motor. Where supply is getting for induction? Supply is getting for induction motor from the alternator. Okay. At what frequency alternator is supplying induction motor, same frequency will be the induction motor stator frequency. Okay, got it? So supplied by 10 pole alternator, which is driven at 600 rpm, means this 10 pole alternator is coupled to some mechanical input and this alternator is running at 600 rpm. See, keep in mind, alternator runs at only one speed, that is called synchronous speed, that's it. Induction motor runs at two speed. One is called synchronous speed and another one is called rotor speed. Okay, got it? So now the alternator is running at that speed, 600 rpm. Then they given, if the motor is running at 970 rpm, so they given the speed of motor runs at 970 rpm. What is this? Speed of rotor of induction motor. Now they are asking, determine percentage slip. Okay. See, what is the formula for percentage slip? Very simple. Ns minus n divided by ns multiplied by 100. That's it. If they ask simply determine slip, means then don't write into 100. Okay. And don't write percentage this side. S is equal to only this much. If they ask determine slip. If they ask determine percentage slip, means then you multiply by 100. See, n is already given. N is given already. See, all this data, ns, n, ns, everything related to induction motor only. Don't take ns value 600. Don't take. Okay. Got it? Now we need to find ns for induction motor. What is ns for induction motor? Once we calculated this, then substitute here, then you will get percentage slip. So what is the predicted answer of ns for induction motor? Ns should be, very good, ns should be more than n. Ns should be more than n. What is n value? 970. Then ns should be more than 970. Then all it is induction motor. Let's see how much we get. See, whatever the alternator data given, from that alternator data you find frequency. Okay. So frequency formula is Pns by 120. So I wrote this equation from this formula itself. Ns is equal to 120f by P. 120f by P. So from this only f is written. F is equal to Pns by 120. Whether alternator or induction motor, ns value, ns formula is 120f by P only. So now substitute. How many number of poles? 10 poles. What is the speed ns? It is running 600 divided by 120. So cancel. 12 1 ja, 12 5 ja, 10 5 ja, 50 hertz. Means the meaning is the alternator is going to produce electrical quantity at what frequency? 50 hertz at this frequency. Now that supply is given to where? Induction motor. So obviously whatever the frequency in the alternator, okay, that frequency will be same for induction motor. Okay. What is this frequency? Stator frequency. One more frequency in the induction motor, that is called rotor frequency. Got it? Stator frequency is 50 Hz. Now with this frequency and this number of poles, calculate ns and you should get ns value more than n. Then only it is induction motor. Otherwise question is wrong. Okay, got it? So fine. Now ns I am going to calculate with the frequency given 120f by P. 120 into, what is the supply frequency? 50. How many number of poles in induction motor? 6 poles. 6 poles. So by doing this, you will get 1000 rpm. So the answer will be 1000 rpm. What students will do now? They will take for induction motor poles, they are going to take 10. Okay. And here they are going to take speed ns 600. This mistake they will do. Evaluator is waiting for that mistake and that evaluator will give 0 marks. Okay. Don't do such mistake. If they give an alternator data, you calculate only frequency of the alternator. Only that frequency you take it to the induction motor side. That's it. And that frequency is supply frequency. This frequency is required to calculate synchronous speed. Okay. See, what is the answer we got? 1000 RPM. 1000 RPM is more than 970 RPM? Yes, it is induction motor. Now, substitute those values here. Okay. NS is how much? 1000 RPM minus 970 is what? N value. Divided by 1000 multiplied by 100. Do it in calculator. Okay, you will get 3%. So percentage slip is how much? 3%. What is the good induction motor range? 1% to 5%. What is the answer we got? 3%. But we can give data, theoretically any data we can give it, and we may get slip value beyond the good induction motor range. Okay, no issues. We can discuss that type of problems also in upcoming lectures. Okay, guys, please pause the video and copy down neatly. Understood now? Alternator data is only namesake. Okay, calculate frequency from the data given in the alternator. Take that frequency and put it on induction motor side. Later, forget everything. Whatever I wrote here, forget about this. Then you concentrate only on induction motor. All this speeds, every parameter related to induction motor only. Don't take this speed. To confuse the students, they will give alternator combination with induction motor to fail the students. Okay? Not like that. Don't think like that. To test the students whether they know the subject or not. Okay? That is the correct way. Okay, pause the video, please copy down. Okay friends, next problem. Now slightly different. Ask this problem in VTU for 5 marks in 18 scheme. 18 scheme, 17 scheme, 15 scheme, 14 scheme. So many schemes. Every 4 years once scheme will be revised. Okay. So syllabus topic is same. Select, we can start friends. Electromotive. Don't worry about some new word is came. Okay. Electromotive force means EMF. If the electromotive in the stator of an 8-pole induction motor, see induction motor in question paper, they can give it in short form, otherwise in words also, induction motor. Now for simply, I taken in short form, okay, IM, as a frequency of 50 Hertz, okay, means there is an induction motor, okay, having 8 poles, and induction motor is taking supply. Okay, in the stator is at a frequency of how much? 50 Hertz. Okay, stator has a frequency of 50 Hertz. And that of rotor, they given rotor frequency also. Rotor frequency is 1.5 Hertz. And question is, at what speed the motor running and what is the slip? Very simple. See, if I know FR and F, I can easily find slip. So we have a relation. FR is nothing but slip times of supply frequency. I know both frequencies. I can easily calculate. Yes. So slip formula will be now FR by F. What is rotor frequency? 1.5. What is supply frequency? 50. 1.5 by 50. How much you will get? 0.03. Do it in calculator, you will get 0.03. So this question is finished. What is the slip? Okay, completed. Next is, what is speed of the motor? Means you have to calculate what is the value of N. To calculate value of N, I need NS value. If I know NS and slip, I can easily calculate N. See, N is calculated by this formula. S is equal to Ns minus N by Ns. I know the value of slip 0.03. Ns, how can I calculate Ns? By using supply frequency and poles. So let me calculate Ns first. 120 F by P. 120 into, what is the supply frequency? 50. How many number of poles? 8 poles. Please do it in calculator and tell me the answer. How much you got? Isparata. How much? 750. Excellent. Okay. 750 RPM. NS is 750 RPM. Excellent. See, if I got NS 750, what should be the value of N to become induction motor, N should be lesser than Ns. Okay, then only it is induction motor. Condition. Every problem is stick on that condition. If you know that condition, you can write some theoretical concepts also. Okay, if needed. Okay, Ns should be more than N. It is called induction motor. Now, take this Ns, substitute here. You know the slip value, then you can easily calculate N. You can use this formula. Otherwise, instead of that, you can use this formula. Okay. If I know Ns and slip, I can calculate rotor speed by this formula. N is equal to Ns into 1 minus slip. What is Ns? 750 rpm into 1 minus slip. What is the value of slip? 0.03. 0.03. So do it in calculator. 1 minus 0.03 you will get 0.97. Multiply by 750. Then you will get an answer 727.5 rpm. Okay. So this is the final answer. See, they are asking at what speed the motor is running. The motor runs at this speed, 727.5 rpm. I am not sure about this, whether 725.7 or 727.5. Please calculate what you got in your calculator. That is the correct answer. Okay. If that is correct, no problem. If not correct, this is correct. Correct equation. What you got answer, that you can write it. Understood? Very easy problem. Pause the video and copy down. Then I will do another problem. Okay friends, this is the last problem in this video in part 1 of problems on induction motor. So in next video I will add another 5 problems. Okay, and in part 3 another 5 to 6 problems. Okay, so let's start this problem. A 6-pole induction motor. How many poles? 6-pole induction motor. This motor is getting supplied from 3-phase 50 Hz supply. Okay, so supply is given to this motor. Okay, what is the frequency of that supply? 50 Hz. Okay, and the given supply as a rotor frequency of 2.3 Hz. They given rotor frequency also. How much? 2.3 Hz. And they are asking calculate percentage slip and also speed of motor. So percentage slip is question mark and rotor speed is also question mark. So how to solve this problem? See, basically first find by knowing supply frequency and poles you find Ns. So Ns I am going to calculate now. Ns is equal to 120 F by P. What is the supply frequency? 50 Hz. 120 into 50. How many number of poles? Very good. 6 pole. So do it in calculator. What is the answer you will get? What is the answer? 1000 rpm. Okay, fine. 1000 rpm. So 1000 rpm. Excellent. Okay, Ns is 1000 rpm. So next is calculate percentage slip. Now percentage slip, see they given data Fr and F. If I know these two data, I can easily find slip. So now we know that Fr is equal to Sf. Then now S is equal to Fr by F. They are asking what? Percentage slip. So you can write percentage slip is equal to multiply by 100. What is Fr? 2.3. What is F? 50 Hz. Multiply by 100. 2.3 by 50. How much we get? 0.046 multiplied by 100. That gives 4.6%. What is the percentage slip value? 4.6%. Good induction motor. What is the range? 1 to 5%. We got within that limit. So the given question data is related to good induction motor. Okay, they can give any data. Need not to worry. If the theoretical data given means you may get 100% also. Need not to worry. Okay, got it. But practically 1% to 5%. So next is speed of motor. See, if I know Ns and slip value, I can easily find speed of induction motor. See now formula is N is equal to n is within the bracket 1 minus s. What is the value of n is 1000 rpm into 1 minus. See here you should write absolute slip value. Don't write 4.6. Okay, here. Okay, that is not correct. You write absolute slip. Absolute slip means fraction. Simply FR by F. Okay, FR by F. FR is 2.3, F is 50. What is the exact value? This 0.046. This value you must write there. So 0.046. So you do it in calculator. First to subtract this two, then multiply by 1000. You will get an answer 954 rpm. So what is the speed of the rotor? See, speed of the rotor also correct. Speed of the motor also correct. Okay. So n is equal to 954 rpm. Got it? So by this problem finished. Okay students, pause the video, copy down neatly. I request all my members, viewers, subscribers, watch the problems videos with a lot of patience. Copy down in your notebook. Same problems will come for university examination. Okay, only they can do data change. Otherwise, ditto question will come for exam. Okay, got it? So we will do another few more problems in the upcoming lectures. Okay guys, meet you on next lecture of few more problems. Okay, will be uploaded soon. So tell your friends to become member to our channel. Okay, and tell about membership details. I am doing classes for the each module revision classes and laboratory viva questions. All these things you tell to your friends. Okay, have a nice day. Take care. Bye bye.